Part 2. Eddy currents. When an induced current flows inside a single conductor, usually in the form of a circular loop, the induced current is called eddy current. Let's take a look at the following experiment about eddy current before we move on.
We will study the effects of eddy current induced in a piece of metal when the metal is placed in a changing magnetic field or moves in a magnetic field. Put a coil of 1,100 turns round the bottom of an iron stand and insert an aluminium ring on the top of the coil. Connect the coil to a DC power supply. Switch on the power supply. What happens to the aluminium ring? Now use an AC power supply. What happens to the aluminium ring? Repeat the experiment with an aluminium ring with a slit. Use the DC power supply, then the AC power supply. What happens to the aluminium ring in each case? Next, we will see what happens when a piece of metal moves in a magnetic field. Suspend an aluminium plate so that it can swing freely about its pivot. Place the plate between two slab-shaped magnets with unlike poles facing each other. Pull the aluminium plate to one side and then release it. What happens to the aluminium plate? Repeat with an aluminium plate with slots. What happens to the aluminium plate this time?
In the first experiment, the ring jumps up at the time when the DC is switched on or off. On the other hand, when AC is used, the ring jumps and keeps floating in mid-air as far as the AC is flowing. For the ring with a slot, on the other hand, it does not jump at all. In the second experiment, the aluminium plate with slots swings for a longer time. The kinetic energy of the plate may retain longer. On the other hand, the kinetic energy of the plate without slot is converted to electrical energy when induced current flows on the plate, and finally converted to heat energy due to Joule heating effect. In figure 5.3m, the metal plate experiences a changing magnetic field, and hence there is induced current flows on the plate inside a single conductor, and so we call such induced current eddy current. In experiment 5e, the eddy current flows in such a direction to oppose the change in magnetic field, which turns out repelling the magnetic pole of the top of the coil, and hence the ring is lifted in mid-air. However, the eddy current stops to flow after a very short time the DC is switched on, and hence there is no more repulsion to lift up the ring. On the other hand, an AC keeps changing the current in the coil, and hence the ring may experience a continuous change of magnetic field. Eddy current flows to and fro like an AC, and there is always a repulsion that lifts up the ring. In the second experiment, an eddy current is induced on the swinging metal plate as shown when the plate enters the magnetic field. There is also induced current flow when the plate is vertical, and after it passes the vertical, as shown here in the diagram. You may use Lenz's law or Faraday's law to verify the direction of the induced current. In the diagrams here, the eddy current is much reduced for slotted plate, and hence the power loss due to eddy current is much reduced. This explains why the slotted plate may swing a longer time.